The Holy Grail of software development. What is the Holy Grail? It's simple. We want to build a piece of software and forget how it works. We just want to use it. We want to design it, bench test it, then ship it with no further bugs in the field. This is possible in digital hardware design. You could design, debug a design on a bench, ship it, and we would have 0 bugs in the field. Even though ICs that make up an electronic circuit are all asynchronous. They're what we call multitasking. Telecom in the 1980s at least had something called the 4 nines culture. They guaranteed a 99.99% uptime. It was so ubiquitous that people would call each other during a power failure on a telephone and say, is the power out at where you are? And they wouldn't even notice that the phone was still working even though there was a power failure. So in software, we have many bugs in the field. We have monthly, weekly, daily updates. We have something that I'm calling GitHub culture, where somebody looks at a repo and says it can't be any good if there weren't any recent pushes to the repo. That's the wrong emphasis. Working code should be perfect. It should need no new modifications. Sam Aaron, for example, teaches 10-year-olds how to create multitasking programs. What's our problem? What's the difference between software and hardware development? That's a rhetorical question. I think it boils down to the use of global variables. I think that all current languages use a hidden global variable. That includes functional programming languages and most CPU architectures. The stack. The stack is a global variable. Having that global variable hidden from view has been causing this accidental complexity. Call and return instructions provided by the hardware implicitly use the stack, and it's a global variable. There's only one copy of it. We talk about things like thread safety, and we have this fiction that multitasking is hard, and all of that stuff is caused by the fact that we use a global variable called the stack.